Hello friends, myself Sudhir Pandurang Soma, lecturer in Mechanical Engineering Department, Brahmadev Dada Mane Polytechnic, Velati. Now, today I will deliver or show PPT on machine design elements. That is the remaining part of Unit 1, that is the fundamentals of design. You see the philosophy, types of loads, factor of safeties. So now we are going to see the stress strain curve for ductile material. First, what is meant by ductility? You know, the ability to be drawn into wire or elongated. Okay, it is known as ductility. So what are the examples of ductile material? Aluminum, gold, copper. These are the drawn into wire. That property is called as ductile material. So you see the stress strain curve. That is the OA represents proportionality limit, upper yield stress point, lower yield stress point, ultimate stress point. That is the E fracture, that is the breaking stress. So we see one by one, that is the what is mean by proportional limit. When the load is applied to a specimen, there is a continuous elongation of the bar from point O to A, where stress is proportional to strain. That is, stress increases at the same time strain also increases. Okay, the line OA represents the proportional limit. The next, elastic limit. If the load increases beyond point A up to the point B, the material will regain its shape and size when the load is remained. This means that the material has elastic properties up to point B. So what is meant by yield point? As you know, if the material is stressed beyond point B, the elastic stage will reach, plastic stage will reach, that is, on removal of load, material will not regain shape and size. Obviously, it includes both the upper and lower yield stress points. So next, what is meant by ultimate stress? At T, the specimen material regains some strength and higher value of stresses are required for higher strain. Obviously, you know what is meant by stress and strain. Stress means when an external force is acted on the body, some of the internal forces are developed to resist these force. So it means the resisting force is called as stress. Means it is the force acting upon area. So what is meant by strain? It is the change upon original. Okay. So stress increases till the point D is reached. So the stress which attain up to this, that is the maximum value, is known as ultimate stress. So what is meant by fracture? Means that is the breaking stress after the specimen has reached the ultimate stress. A small neck is formed which decrease cross sectional area of the specimen. Okay, so next slide we'll see what is mean by stress concentration? So it is the location in a machine component where stress is concentrated. A component is stronger when force is evenly distributed over its cross sectional area. So obviously a reduction in area, for example, caused by a crack results in a localized increase in stress. During the design of any actual machine component, discontinuities in the any machine part are there due to keyway, threaded holes, grooves and steps are present on that component, which is the functional requirement to perform their functions. There are several types of stresses acts on the element such as tensile or compressive stress, bending and twisting, that is torsional shear stress. So, whenever a machine component changes the shape of its cross section, stress distribution pattern no longer holds good, and the nearby of the discontinuities is different. So, what does it mean stress concentration? The irregularity in the high stress distribution caused by discontinuities. You can define in also abrupt changes of cross section form is called stress concentration. So next slide you see the methods of reducing stress concentration. It indicates different parameters, means it occurs for all kinds of stresses in the presence of fillets, notches, keyways, splines, surface roughness, there is scratches. Okay. So what are the remedies for reduce the stress concentration? You see the tie rod with hole, shaft with keyway, then threaded components. One important thing effect of stress concentration cannot be completely eliminated, but its effect can be reduced by slightly altering the geometry of the components. Following figure shows the methods are adopted for reducing stress concentration. In that, some of the additional notches and holes in tension members, means use of multiple notches, drilling additional hole, removing roughness, and next you see the avoiding sharp corners by providing a fillet radius at sharp corners, undercutting notch for member in bending. The next you see reduction of stress concentration in threaded member. Then next, by providing small holes near big hole, that is, or drilling additional holes for shaft. In this way we reduce some of the amount of stress concentrations. So next slide it designate the how you will designate the standards of materials, means there are n number of materials are present. So how you will designate? According to IS standard specifications, different materials are designated by using alphabets followed by some numbers. So some of the examples are FE 200 means it contains a steel with minimum yield strength of 200 Newton per mm square. The next you will see 35C8 means it contains plain carbon steels contain 0.35% carbon, 0.8% manganese. The next you will see the 20Cr18Ni2, that is the alloy steel containing average 0.2% carbon, 18% chromium and 2% nickel. So in this way the different materials are designated as per the IS standard. So next slide you see the theories of elastic failure. Theories of elastic failure. You know there are number of machine components that are subjected to several type of loads. Simultaneously, the combined stresses are induced in it, such as torsional shear, bending stress, etc. Mainly, the failure of such component are classified into two groups. That is the elastic failure and yielding. That is the and fracture. The elastic failure result in plastic deformation, which make machine component unfit to perform its function satisfactorily. The theories of elastic failure provide relationship between the strength of machine component subjected to complex state of stress. So some of the theories of elastic failure that are listed: maximum principal stress theory, it can also called as Rankine theory. It works on brittle material. This theory states that elastic failure occur when the greatest principal stress reaches the elastic limit value in simple tension test, irrespective of the value of other two principal stress. So factor of safety takes into consideration sigma T is equal to sigma yt upon fs for ductile materials, and for brittle materials is it given, that is the ultimate stress divided by factor of safety. While designing of any machine component, it is taken into consideration for brittle material. For example, spindle of screw jack, machine bed, C-frame, overhang crank. So next theory, that is the maximum shear stress theory. You can also call as Guest theory or Tresca's theory. According to this theory, the elastic failure, that is the yield, occur at a point in a member when the maximum shear stress in a biaxial stress system reaches value equal to shear stress at yield point in simple tension test. Obviously, the formula has given, that is the tau max is equal to yt divided by fs, means shear stress at yield point. You know the shear stress at yield point is equal to 1/2 of yield stress in tension. It can also return tau max is equal to sigma yt divided by 2fs. So obviously this theory is mostly used for ductile materials, means maximum shear stress theory. So what are the applications of this theory? while designing of machine component for ductile material. For example, spring, key, crankshaft, propeller shaft. Okay. So next slide, you see what is mean by creep. The chart shows to understand the phenomenon of creep completely. This following diagram will be helpful. So first of all, we know what is mean by creep. Can be defined as the slow and progressive deformation of a material with time under a constant stress. You see the figure, if a stress below the proportional limit is applied on initial tension, that is an elastic strain will occur immediately upon application of the load, and regardless of the duration of application, the strain will remain constant. So this is the concept of creep strain and creep curve. One more thing I will tell you, in first stage creep continues at a decreasing rate that becomes approximately constant during the second stage. The beginning of the third stage is marked by rapid increase in creep rate. So the strain OC may be entirely elastic or elastic plus plastic, depending upon the material, the temperature and the stress. At elevated temperature, a strain OC occurs upon the application of the same stress F. OC being greater than OA, partly to the lower value of the modulus of elasticity. Thank you.